Welcome to another episode of the Tech Transfer Podcast. I'm Dave Brown. I'm here with Bennett Mortensen and Adam Stevens, and we are each going to talk about some technologies that are available to license currently from BYU's Tech Transfer Office. So, Bennett, what's the first one on your list?
Yeah, so the first one that came to mind is one that's been in development for a while here at BYU, but it's a constant force exercise machine. So if you think about exercise machines in general, one of the primary problems, if you want to call it a problem, is that when you're using them, typically you have some sort of curved force profile, which is different from using free weights, right? If you lift 20 pounds with free weights, it's 20 pounds from the bottom of the exercise all the way up to the top. But with any kind of exercise equipment, it tends to, start at zero, and then it has kind of a gradual curve up to the peak, which may be 20 pounds, maybe 21, right? There's some variability there. So, compliant mechanisms here at BYU, we do a lot of that here, which is great. And through the use of compliant mechanisms, the research group has been able to develop an exercise machine that provides a near constant force profile with an exercise machine, which is a huge benefit to kind of the exercise community, overcomes that problem. And they did so by using some, off-the-shelf components, manufacturing techniques, so it's easily deployable into the field in the industry.
And I know I've seen a prototype of that at some point in the past. So if someone wanted to commercialize this, I guess they would come to you, license the technology, and then build a machine around this mechanism. Is that?
Yeah, absolutely. And I think we actually have several machines floating around on campus. So if somebody's interested, reach out to me. I could probably track one down for you. You could come on campus if you're interested, try it out, get a workout in, see if you like it, and then we'll go from there.
Okay, great. Thanks, Bennett. So the first one on my list is a software technology. If you're shopping for a house, how do you know that the house will be quiet around the clock? Like, you might buy a house and you think that it's a nice, peaceful neighborhood, but actually really large trucks drive by at 3 o'clock every morning, or there's a train that's closer than you thought it was. So our technology that we're calling the Vroom App it combines several data sets, and it predicts what the noise will be, the street noise in a certain location. So if you're buying a house, you can imagine this would be useful. You could go to a site like Zillow, or maybe look on Google Maps or something, have a plugin or some kind of layover that charts out where the noise is at different times of day. You could also potentially use this for an Airbnb or VRBO situation. You're going on vacation and you don't know the area you're going to. It'd be nice to stay somewhere quiet. So that's what this app is. It was kind of designed as a standalone app, but like I say, I think it has a lot of potential as a Chrome plugin or something like that as well.
Yeah, absolutely.
So good.
Imagine that a lot of people, they're going to look at houses and they show up there at 2 o'clock in the afternoon when everyone's at work and they don't know what's really going on in the neighborhood. So that has a lot of promise.
Totally. They say that when you're buying a house, you should spend 24 hours and you should stay overnight, but probably almost no one does that. So here's a solution.
Yeah, good. So the first product that I have is a prosthetic venous valve for treating varicose veins. A lot of the treatments that are out there right now are basically inadequate. They don't last long enough. So people are going back in for repeat treatments. And they're not treating the root cause of the problem. They're just pulling out bad veins or destroying them. What this does is it reestablishes the valves in the veins that allow the blood flow to only go in one direction and go in the direction that they need to, and that will address the pain and avoid clots and some of the other issues that happen with varicose veins. Existing treatments also, they've had some valves that have been tried, but the materials that they have used in the past have been incompatible with the body, and so that leads to clotting and other issues. And these are new Carbon Nanotube valves that will avoid a lot of those issues and be a permanent solution instead of just a temporary one.
Okay, and I think on most of these technologies we're talking about, we have issued patents as well, right? Or at least some really strong pending protection.
Yeah, so on this one, the patent is still pending, but there are claims that have been allowed. So patent could issue at any day at this point.
Okay, nice. Good. All right, Bennett, what's your next one?
Yeah, so the second one on my list, and maybe a little bit of context here for entrepreneurs, I feel like this is a really great B2B technology. Most entrepreneurs, not most, but a lot of entrepreneurs, you get kind of fixated on that direct-to-consumer kind of mindset. What do I use in my life? What would be useful? But this one, it's a noise reduction technology for vacuum-assisted toilets. So if you've ever been on a cruise or an airplane, that type of technology, it reduces the noise level, specifically at the opening and closing of the valve. And so really drops down the noise level. I think for a startup entrepreneur, this could be a great piece of technology for a B2B type of business, right? Where you're selling to cruise lines, you're selling to electronics manufacturers, anybody who has clean room technologies where they use vacuum-assisted toilets, airlines, tremendous piece of technology that really would set you apart from the competition in what is probably the most noticeable aspect of using a vacuum-assisted toilet, which is the noise level. So,
terrific. And this is, if it's in an airplane, you start thinking about the weight of it, but this is a very lightweight solution to it.
Yeah. It's essentially a dual valve configuration, and then you adjust the timing of those valves to reduce the basically pressure differential at that onset of when you're using the vacuum. And so reduces the noise tremendously, not a ton of weight. And then, every airplane has 2 or 3 bathrooms. Every cruise line has hundreds, right? Maybe even thousands. And so I think airlines are definitely one direction to go, definitely look into that. But cruise lines, I think, is a huge opportunity for this technology.
Okay. Terrific. Great. All right. The next one on my list, another software innovation, is called the Surveyor App. So we have a couple of professors here who do archaeological surveys. Anytime you want to build a new commercial building, say it's a new Walmart or whatever store, they have to have surveyors come in and look for archaeological ruins in the site. There are federal and state laws governing this, and there are reports that they go through. So this is an accepted expense for starting a new project, but you have to comply with the government regulations. And surveying is an industry, like many industries, where people haven't developed a lot of software technology for these applications. So surveyors are out there with a stack of papers, writing notes, and then getting home later, submitting forms online to the government. So our professors, and they've been using this for, I think, about 7 years. So they've iterated through many versions of the software. It's software where you enter your information in the field and it is uploaded to the form, and you've submitted your report to the government. So very slick. Yeah, people often come to our office saying, well, look, is there something that's really market ready, something I could just take and run with and start selling? And this would be an example. So Survey App, reach out to me if you're interested in pursuing that one. Okay, Adam, what other one were you thinking of?
Yeah, so the one I'm thinking of also is a diagnostics tool technology that will be really useful in identifying microorganisms. And it becomes really important in situations, for example, like sepsis, where you've got sepsis caused by oftentimes an antibiotic-resistant organism. And in those kinds of situations, time is of the essence. And what they typically would do nowadays is they take the sample and they're going to do a culture to see what it's resistant to. They'll try different antibiotics. And in the meantime, they'll start treating with a broad spectrum antibiotic, which leads to problems with more antibiotic resistance. And so it's really not the ideal situation to have. And so then 48 hours later, you see, okay, the antibiotic B killed the organism. And so they can then treat with that antibiotic and have the focused treatment. But by then the patient's gotten sicker and maybe has died. So it's a bad situation. And so what a lot of people try to do now is they try to do PCR, polymerase chain reaction treatments, and start identification instead, and specifically identify the organism. But then there's a lot of preparation steps that are involved, and there's a lot of risk of contamination getting in the way of proper identification and false negatives and things of that sort. And so a way a lot of people have got is through microfluidics, and now they're using very small samples. The risks of contamination are much lower, but the preparation steps in creating the microfluidic detection mechanisms are multi-step. They're involved, and they aren't very repeatable. So you get one that works really well one time and another time it doesn't. And so what the technology that we've got is a single step for creating your a polymer monolith formation that's porous, that has your capture molecule attached to it in a way that is repeatable and very easy to manufacture in a single step, by having that incorporated into the polymer mixture before it's polymerized. So instead of creating your polymer structure and then trying to attach the identification molecule after the fact, you're mixed in, you have very consistent surface manifestation of the attachment molecule, and you can then identify much more readily through the microfluidic mechanisms that people are already used to. So it's great for manufacturing. It's single step. It's great for repeatability, and it has a lot of applications. It could be medical. It could be any kind of way you want to have repeatable identification of microorganisms.
Okay, so Adam, would the product be a machine in a lab and samples are being sent in, or is this something where you're in the hospital taking tests?
So this is creating the tests. So you can create the tests that you then sell to the hospitals. You can create the tests that you could sell to other scientists when they want to identify organisms. You're creating these structures that are, like I said, they're repeatable, creatable en masse, and then you can then send them out and use that, and they can be used elsewhere.
Okay, so if an entrepreneur comes and licenses this from BYU, they would talk to you and they license this, then what they would be doing is setting up a business where they're creating different tests. So maybe they create the MRSA test and they're selling kits that they send out to the hospitals or whatever. And then there's another test they take for some other deadly bacteria and so on. Is that how it works?
Yes. And they can have a test that, with microfluidics, you can do tests that will detect dozens or hundreds of bacteria at once with a single sample that's sending through the microfluidic sample. And that's, so that you can have tests that have different ranges of what they can detect. So it's not be a single microorganism per single test, but it can be a test kit that will identify, okay, you've got this specific microbiotic or antibiotic resistant type of bacteria. So you need to use instead this other type of antibiotic.
Okay. Wow. Sounds great. All right, Bennett, what's the last one on your list?
Okay. The last one that I have on my list is actually it's hasn't been granted yet, but we've received basically notification that it will be granted soon, right? Is an internal cutting or gripping mechanism developed specifically for like surgical uses. So laparoscopic surgery, right? You have a small hole, you're going in there. Obviously, if you're taking in and out different tools all the time, you're, delaying the surgery, how long it's going to take, possibly introducing microbes, right, into that as you're going in and out. So this is something where you could go in and have this internal cutting mechanism in the surgery ready to use whenever you need it. So if you could go in, maybe grab a piece of tissue, pull it into the tube, snip off a piece, right, and get your biopsy all in one motion. Or you could potentially use it for suturing, right? You're in there, you're doing these sutures, you need something to clip off each one as you're going along, or clip off once you're finished. You don't have to bring in a separate tool. You have that internal to the implementing device that can just make those cuts for you, or those grips holding things in place. So very small, or can be very small, or it could be used for larger types of applications. But again, this is a newly granted or about to be granted patent for BYU for this technology.
That's great. And we've had at least a couple laparoscopic tools that have been commercialized. One, I think, went to an established company, and then one is a startup, Bloom Surgical, that we've talked about recently. So this is presumably from the same group that created those tools, right?
Yeah, and I think this would be a great addition to, their current kind of licensing portfolio, or if there's somebody else out there who's interested in getting into the medical space, I think this would be a fairly low barrier to entry to get into that space for sure.
Okay. Well, terrific. All right, my third one and the last one on our list here today is also medical. This is an app with personalized exercise recommendations to reduce your blood pressure. So one of our professors, Jason Gifford's, got a lot of publicity in the media last year because he came up with a way of calculating personalized exercise programs. So he might give you some exercises to perform, you time yourself, and then going forward, it can give you feedback on whether you're working hard enough. Like maybe you should be working harder, and it'll tell you that. That was idea number one. But this iteration is specifically geared towards blood pressure. So you enter some demographic information, take some tests using the app, and then it makes recommendations to you of what you should be doing to control your blood pressure, to reduce your blood pressure. It tracks your pressure over time and also has you retake tests every 4 to 6 weeks so that you can update your recommendations and make sure that you're improving. So this is taking his original idea, I think, but targeted at a major area of interest, people trying to control their blood pressure. So it seems like it has a lot of potential, good hard science behind it, and would be pretty quick to market, I would think. So, all right, well, that's a roundup. That's 8 technologies. People are always coming to us asking us, what can we license or what's available from BYU? There are hundreds of answers to that question. We've got a lot of technologies to share with people, but these are 8 to get you started. So reach out to us if you have questions about any one of those. All right, thanks, guys.
Thank you.
Thank you.